Hi, in today's lecture I'm gonna explain for you how to make a revolve command in Dynamo, whether it goes for a surface revolve or a solid revolve. As in Dynamo, as in any other application, any other graphic package, you will need a profile and you will need an axis for the revolution. So let's have a look of how to do that. First, I'm gonna need a couple of points, so I'm gonna just define a line as a very basic profile. So probably I'll need 2 points, and let's have a look also at a code block. Let's go like 5, and let's go 0. So if this point has an x of 5 and a z of 0, so that's my point. Let's zoom in a little bit. So that's my first point. So I'm gonna have a copy of those and paste for those. So putting that aside, and let's go 5 by 5. That's 2 points. Probably let's make the x less, so let's go 3 here. So those 2 points here, I'm gonna create line to connect between. So that's my line, and it's based on start and end point. So that's the start, that's the end point. So easy. Now that's the profile. It's very basic profile. It's a 2D profile. Now in order to make a revolution, that's the revolve. 2 types again. That's a solid, so that's the profile C, that's the closed shape, and that's the axis of the revolution. And while this guy is a surface, that's a solid, by the way, as you can see here. The surface revolution, you can see the profile is open, and that's the axis, and here we go, we can make a surface. So I'll start up by the easy one, which is the surface. So just to click here, you get this node. It's basically need for or asking you for a profile. That's the profile. Let's connect it. See, it immediately goes and created this, as you can see. So what else it need? It needs the axis for the revolution, and the axis is based on a point, which is this guy, which has been by default, it's the origin. So here, axis of direction, it's by default Z. And then it's by default defined here by 3 points, which is 0, 0, and then 1. So that's meaning the Z direction. And start is the default value of a 0. So here, and then sweep angle of 180. So if you want to make a closed shape, of course you need to go at 360 and close that shape, and so on 90 if you want to just a quarter of it, and so on. So if you want something else, any other axis, probably you might need to define another point. So if you go here and copy that guy and paste that guy again, and just let's say this point is also located on a 0 for an axis of Z, and here in the X, let's go 2. Alright, then connecting this as an origin, you can see that now the rotation, the axis is now changed, and the object gonna revolve around this guy, as you can see. And of course, if you are intending to define an axis direction, just go as Z.Axis, and that's the the axis of the rotation, which is already by default. So it's render this as an obsolete. So let's go X-axis, for example, X-axis, and then we connect that guy, and then we're gonna have a totally different rotation or revolution axis. Anyway, let's remove that, and let's remove that guy also, getting rid of all that extra thing. I'm gonna accept the revolution around the origin area. So that's it. Let's go zoom in here, and let's go make this a 360, and that's a surface revolution in its basic shape, whether it's fully closed by 360 or it's fully sorry, or it's half or open. It's if you can just go ahead and here and double click. Let's give it another value, but this time for the start angle, and notice that that won't affect the whole thing. And here it's accepting the value. It's a double value. It's starting by 0, even if you want to change that. So to define that in a specific point, and then it's expecting you to change or the length for that in a specific direction. So it's going to rotate that 360 degree from that specific point, which is always assumed as a 0. If you want to go a 90, for example, it's going to go that way. If you go minus 90, it should go the other way around. So that can help you to fill the gaps if you want to make uncompleted geometries. Anyway, I'm going to get that back to 360. That's the profile for the surface, and now probably the question popping up in your mind, how about closing those gaps and staying in a surface condition? So again, I'm gonna unwire that, pushing that aside. So probably we need more points, so I'm gonna give this as a copy and then a paste. Now if this is a 3 and that's a 3 by 5, so I want to keep the 5 in the Z and make this one a 0, and then I'm gonna just copy that guy by itself and paste it by itself and just get rid of all the wiring, assuming its value as a 0, 0. Now that's important. Now we need, in order to make more than one line, actually we need a polyline. So let's say goodbye for that guy for now, and probably we need a list. So where is this other 4 points actually? So now let's go ahead and do that. So that's the first. Okay, that's the first, or I can just keep it for the last, it's up to you. Let's go that first, and then which is the second? This guy, okay, is the second, and then that's the third, and then that's the fourth. And if we now created a polygon as such, and then doing this as a closed geometry, so if we intend to make this as our profile, and then we connect that guy here, notice that we get an error message. It's telling us it's failed and you cannot revolve around your own geometry. So that's the important thing. That's the difference. For example, if you want to make this in a 3D Studio Max and stay in a surface condition, that's not allowable. So you need to get rid of this, that vertical line. You're not supposed to make a closed geometry. If you're gonna make a closed geometry, in this case, it's gonna be considered as a solid. Probably before we go on solid, maybe we need to push that a little bit away from the revolution, because that's the revolution axis, if you remember. It's still on the coordination original 0, 0. So let's push that away from 0. So wherever we find 0, that's for the Z, right? So now we need that the 0 goes for the X. Let's make it 1. That's 1. Oh, look, it's immediately created this. So it's helped me to create the geometry. So it's actually accepting the solid condition, and I bet that it's been tapering down. Yeah, that's right. And if you want it to be a full through, so probably you might need this guy. Just double click and make that 1. So that's gonna be running through like as you can see, and it's based, or it's been dealt with as a fully surface geometry, not as solid. Shouldn't define the actual volume inside, but it's still allowing the thing. So it's allow actually to create, as I said, let's see, that's the axis again of the revolution. So it's allow to use a closed profile, sorry for that, but not that axis or not that profile, any part of it to overlap with the main revolution axis. You have to keep your distance away. Now, can we close this gap and make this without the hole? And I'll tell you to go and make a cylindrical. There's a note for making a cylindrical objects. You don't need to do that here, but in case of the curiosity goes up in your head. So let's see. First, we need to get rid of this. Getting this back to the 0, as we said, and like this error message. Yep. So this guy, which one is which? So this, and then that's the second, and then that the third, and then that's the fourth. Beautiful. So if we get rid of the last one, no, it shouldn't be it. So it should be 4, but the generation of that should be different. So instead of using this, I probably need to go ahead and define 3 points, or at least one of those should be deleted. Let me have a look at that geometry for a second. So 1, 2, 3, 4 points, and we can go ahead and define those as a lines, for example. So a starting point and ending point. So instead of listing that, let's just remove that. So that's point, and that's point, that's point. Good. So this one, that's the start point. Beautiful. So this guy, and then this guy, that's the end. Now we can just copy that and paste that. What if we go ahead and we end up by this guy, which is that's the start point for this guy, and the end point should go to this guy. Now just edit and paste again. So that's the start now, and this guy is the end. So just the 3 lines, as you can see, and those are 3 lines again. So you cannot make any of those as a polyline, because that type of polygon is actually depending on points. So what we really need is a poly or a join, whatever we have in here. That's for surface actually, and that join curves. So can we just go ahead and combine this guy and this guy? So what's going to happen in here? Yeah, beautiful. It's actually defining for us as poly. I can just make a list, isn't it? And then just define. You can make a list create. So I'm gonna combine those two together. Let's see what's gonna happen, and then connect them to this guy. Is it gonna work? No. Good. So let's get to move that aside and removing this guy. So probably if I repeated this one, let's have a look, and I can connect this guy to this guy and see. Beautiful. Now we have this. No need for that. Let's connect this one to this one, and as you can see, it end up really nice and neat. But again, this is not solid. This is just as I said again, this is just a surface. And if you want to make it just a cylindrical, there is a cylinder node you can just go ahead and use, and instead of the whole suffering thing that we've been the whole thing doing in the couple of last minutes. Now if you want to go ahead and now experience the need to make a solid revolution, Again, it's very basic to what we've done in a couple of seconds ago, and probably you don't need all that again. So probably you need the same 4 points. Again, List.Create, and let's make those things. So that's the first. I should have arranged that from the beginning. So that's the first. Again, that's the second, third, and fourth. And then again, we return to our Polygon.ByPoints. And now that's my polygon. And now we need to revolve. So just write down here, revolve. Again, that's a solid one. So if I go, that's my profile, again, it's going to give me a warning message. Again, because of the overlap thing that we talked about before. So probably we need to change that guy, make this one 1. And then we give this value to, see the section, how it's been cut really nice. In order to make it fully through, you probably need to give this point also number 1, and now we get this nice and neat done. That's, again, it's very look like surface, but this is a solid definition, so you have the volume definition for this geometry ready for you. And if you want it to be full sweep 360, you can just connect that 360 and it's gonna be, you know, like ready for you. Anyway, I'm gonna save that node, and I'm just gonna call it basic revolution. And now, if I want to make a little bit more complicated geometries out of what we've been doing, let's have a look of cases where those points actually much more complicated and they are not lines. And I'll show you in a bit the differences between making lines and curves. Anyway, let's go ahead and we create exactly 5 points. So we are actually having here 4. So I'm gonna remove that, copy that again, and I paste it once. That's the 4th point, and then I pasted it twice. That's the 2nd one. So let's do something a little bit more complicated. So in the first one, let's go for the X around 34, and the Z of 0, I'm gonna keep that. Probably we go out a little bit. And the second point, again, X is 5, while Z is 27. Then we go 6. That's the second point, and then we go 6. And we go 41, or 40. And then 9. And then 70. And the last point is 6 with, let's say, something big like 100. So if I zoom out again, that's a new profile to consider to create a revolution for. So those 5 points are the points that I want to create an object for them. Now I'm gonna make a list for it, and this list of course needs 5 items, and I'm gonna connect each one of them to the list, and then I'm gonna create a NURBS here, a NURB curve. By points, which is this guy. Sorry, this one. Now, this type of geometry, it have its own unique features when you create it and when you rotate it around the main axis. Let's have a look, and let's generate a surface or a revolution for that. I'm gonna make a surface, and I'm gonna create this one here. I'm gonna depend on the basic, which is the X-axis. Probably I'm gonna go, let's have a look. Let's see what we have. Let's minus 90 or whatever value we have. If we make this, and this guy, let's go like this, you know, like it's a quarter of the whole thing. We can make go ahead and we make this like a 360 or 270, like this. So it's going to be all or the whole thing without that sector, for example. Or we can go ahead and make 360 just for the experimental sake. That's the surface, and you can see that you know, the curvature here is very important and very critical in the same time. If this is a complete arc, or this is a clean arc, or this is a sector of a rectangle, of a circle, then when you divide it, the segment, when you divide that line, or you're gonna divide that surface equally by a parameter, surface.parameter point, a surface point at a parameter, it should be a divide equally. When you divide this based on a very NURB or complicated geometry or complicated curve, you have to be very aware that points will not be distributed, and that might be really an issue for you. Anyway, so that's really a point to be considered. So if I go a surface dot point at parameter, so if I go here and I connect that surface, let's have a look of what we can have, for example, explaining this for you. So instead of just giving this a value, of course I might need to, you know, select those guys, and you go and remove the preview for the points, so they don't appear, I mean, in here, neither for the list itself. Anyway, what else? Beautiful. Now if I go here 0, 2 dots and then 1, that means from the start to the end of that object, and then let's say I want to make a division or a 10 pieces or a 10 segments or steps between, and then I connect that guy here, you might notice that the points actually getting closer to each other. See, this distance between here to here is really big, while here is shorter. See, this is how big, and see, this is how small distance. And why? Because this is as this area, it's really more curved or more complicated curvature here rather than here simple or here simple. That's why those are really big. So be careful when you use this type of methods to generate points on a line or points on a surface. If I was you, I will just go ahead and use 0.1, and now you're gonna get a better results of the division. Or you have to go ahead and create planes, and those planes will divide that surface equally for you, and then you go ahead and, you know, like creating the geometry that intersect with those surfaces, and create the lines that you know, run over that points or run over that surface correctly. Anyway, so getting back to the topic, so if I want, I'm just going to remove that just to show you. That's the geometry. What if we want to continue that here? So I'm gonna take that, I'm gonna make fill in this object. So I can just select the whole thing and go ahead here, copy, and then go ahead paste, just to play with this revolution thing or surface revolve. Okay, now we have two surfaces above each other. Let's go here, and instead of 270, let's make minus 90. See, now I can, you know, I can now create it, or actually I created the missing, you know, part of that. See, lovely. So I can make the whole thing that's solid, and this guy maybe I can make it like a glass, define it with a different glass. Maybe this is goes a subdivision, and this guy goes for a special or normal cladding system, curtain wall system. Or I can even go ahead and just change the parameter of that to make it different. So for example, I will go here, and instead of 34 very big, I'll make it 16 or 15. Okay, see, so I'm gonna just define that, just making a shell or a surface here, and I'm gonna keep the rest, probably the highest point. Let's change the last point here, and instead of 100, sorry, here, a very high point, I'm gonna make it 90. Okay, so when you do that, you can see that's actually a mess in here, because that doesn't follow this, so it's okay. Let's go a little bit away, and probably we need to change this. How much? 8.1 or 8.2? See, 8.15 to be exactly placed in this, as you can see. So by that we defined that object, and then we make a copy that actually completed, and then after that we change the properties of that new shell or that new surface. It gives us an object, as you can see here, that's slightly different, and how we can control that to get a good manipulation of that radius here and that height here, and that to find out the radius. A little bit of I like a little bit of experience, the correct number to get this, so don't get confused if you don't find the same result or not match 100%. Anyway, so that's it for today. I just wanted to show you, or to introduce you actually, to make your own revolution or own surface or solid revolve geometries, as you can see in this example, starting up from a very basic line profile, ending up more curvature profile. And don't forget, if it's line or if it's curved, a fully correct curve like arc, like part of a circle, it's gonna be easily divided. And again, if it's a NURB and it have very complicated curve part, so the most complicated part will be having more intense segments in order to define it correctly, while the most straight will have less segments. And there's lots of method to overcome this issue. We're gonna have a look later on it. So I wish to see you in the next videos. I'm gonna try to add some cladding and subdivisions or panels to those two geometries. Wish that you find this tutorial useful. Thank you very much and have a good day.